now we want to find an algorithm that will most correctly predict which category these images are in. So there's this thing called accuracy, where you take all of the predictions that your algorithm makes during the testing phase, and then you find the fraction that are correct. And it turns out accuracy is a really good numeric metric for how well this model works for us. And then we can find accuracy by importing this Python library called sklearn. And basically a library is just a collection of pre-written code or functions, and it just gives you a lot more capabilities. And sklearn is a pretty common one for machine learning. So as we go through all of our models, we're just going to check each of them for accuracy. So we did some preliminary models for k-nearest neighbors and decision trees, and we don't really have the time to get into how they work, but the important part is that they are not very accurate. So for these k-nearest neighbor ones, you can see that the accuracy is only about like 50%, and then for decision trees, it's like 25, 30%. And for context, because we're sorting the images into 4 different categories, like even random guessing will get you 25%. So we need to find a better model. So this is where neural networks come in, and neural networks are an algorithm that are really good for finding complex patterns. And so this image shows like the structure of a single neural network node, and you've got your input. So for our project, we're going to be inputting all the pixel values for an image of a driver. And then you've got your weights and your bias, and so your inputs are just going to like go through this process until eventually it gets to an output, and that output is like what the model predicts, like which category it thinks it is. And basically during the training phase, the model will go back and just change the weights and bias little by little until it gets to the most accurate predictions that it thinks it can get. And then you can stack a bunch of different layers and different nodes on top of each other until you get a more complex neural network. And as it gets more complex, you want to try and make it more accurate.
Okay, so how does this neural